devices and digital integrated circuits. Today we are going to see other characteristics of digital logic families. Okay, so first one is power dissipation. Power dissipation is nothing but it is amount of power drawn from the supply during static and dynamic condition. In static condition, the power dissipated in a logic circuit is called as static power consumption, and the dynamic power is nothing but a consumption that takes place in a dynamic condition or switching transitions. The static power consumption is the power dissipated in the logic gate when the device is either on or off. Okay, so during the transition from on to off or on to off, the power consumed in the gate is called as dynamic power. Okay, so the power dissipation is directly proportional to the switching frequency and inversely proportional with the cycle time. CMOS ICs have very low power consumption at low frequency. If frequency increases, power dissipation also increases. The average power dissipation is determined by the simplest expression VCC IC, and where IC is the average um, value of current, and generally the power dissipation varies in the range of millivolts. Okay, next one is fan in and fan out. Fan in is nothing but the number of inputs a gate has. If two input AND gate has fan in of 2, and a 3 input NAND gate has a fan in of 3. So a NOT gate always has a fan in of 1. Generally, a delay of operation of any gate increases with increasing fan in quadratically. Gate delay is the delay offered by a gate for the signal applied at the input terminals before it reaches the gate output. Gate delay is also called as propagation delay. Fan out. The number of similar logic gates driven by a single logic gate. While a logic gate has high fan in, it is advantageous to design integrated chips as less number of driving circuits are required. The fan out really depends on the amount of electric current gate can source or sink while driving other gates. So, when a logic gate output with more than its rate of fan out, and but the particular logic gate has certain effects. Okay, the operating temperature of the device will be increased. So, when the temperature is increased, the reliability of the device will be reduced, and eventually the device will fail. Okay, so propagation delay will be increased, and it may be about a specified value. So when the output rise and fall times may also be increased beyond the given specification. Okay. So in a lower state, the output value VOL. So low output. Okay. So it may increase about the maximum value of VOL. So in lower state, the output voltage may increase to a maximum value. Okay, so same ways in the high state, the output voltage, okay, VOH, it is also called as output high voltage. Okay, so it may decrease below a minimum value of VOH. So next one is we are going to see is noise margin. Noise margin. So noise is always present in electronic circuits due to stray electric and magnetic field. This signal is unwanted and spurious. Sometimes the noise signal distorts the output voltage of the gate. Noise immunity of a logic gate means the circuit's ability to tolerate noise in order to correctly recognize logic 0 and logic 1 states. Noise immunity is measured quantitatively, which is known as noise margin. There are two types of noise margin, such as low noise margin and high noise margin. Low noise margin LNM. Okay, VNL is nothing but largest noise amplitude that is guaranteed for no change of the output voltage level when the input voltage of the logic gate is in the low interval. The low noise margin is measured by the expression VNL is equal to VIL minus VOL. IL is input low input voltage and OL is low output voltage. So, likewise, high noise margin HNM is defined as VNH and it is called as largest noise amplitude, that is guaranteed for no change of output voltage level when the input voltage level of the logic gate is in the high interval. So it is measured by VNH is equal to VOH minus V high H. Okay. So VOH is equal to output high voltage and VIH is equal to input high voltage. Next one is cost and availability. Okay, the cost of the digital IC always depends upon the quantity that are manufactured. Okay, the designer always try to design low cost ICs to the quantities of ICs that are used in larger in quantity. And the last characteristics of logic family is availability. To choose a logic family for a particular application, availability is an important parameter. Availability can be considered in different ways. First one is popularity of the logic family. The popularity of a particular logic family depends upon the users and the digital circuit designers. If the application of a logic family is more, a large number of ICs of that logic family will be manufactured. Therefore, the cost per IC will be very small and easily available in the market. The second point is the breadth of the logic family. The breadth of the logic family means it's nothing but a number of different logic functions ICs that are available. The complex functions would have to be constructed using basic ICs. For example, the TTL logic families has a very good popularity and high breadth over other logic families. And the third point is availability of complement outputs. If the complement of outputs is available in the ICs, the additional inverter is not required to invert the output. So, in next class, we will see about RTL in detail. Thank you.